everyone. So, real quickly, we are going to review the reading from 2 days ago. How fast do things go? And this is just to make sure we're all on the same page with how to do the questions at the end and also what the reading was about. So, this reading introduced you to average speed, speed in general, and where we see it in our real world and how fast things move in our real world. So, I'm not going to read through this whole thing. I'm just going to scroll through here. You saw some interesting things with this chart here with some of the slowest animals on Earth. Very interesting. And then it talks a little bit about energy, and it talks about some of the fastest animals in the world. The Zoo America has a peregrine falcon, and they're one of my favorite animals. The fastest bird or animal ever. So pretty cool. When they dive fast. Obviously, you probably know about the cheetah. Talk about the fastest humans, which right now is currently Usain Bolt, who is ridiculously fast. And then you have some women's world records for running. And then they keep going in how we're trying to get faster and faster as a human race. And then this I find very interesting. Just some random speed records. Right, so some of the things to keep in mind are the speed of sound and the speed of light. So when you hear of light years, it's how far the light would travel in 1 year. That is 1 light year. So that's an insane distance. Okay, so just some interesting things there. Now, down here I set up my questions, and that's where we're going to go to next. All right, so let's take a look here at question number 1. So our first step is read the problem. So let's do that. Sarah the cheetah ran a 100-meter dash in 5.95 seconds at the Cincinnati Zoo, setting a new world record for mammals. What was Sarah's speed in meters per second? So, what are we trying to find here? We are trying to find our speed. They say it right down here. So the first thing I'm going to do is highlight that in orange. And they're asking me, what is Sarah's speed in meters per second? Now, that's step 1. So now I'm going to go over to my triangle, and using our strategy here, I'm going to cover up or erase that V, because that is what I'm trying to find. So what am I left with? I am left with triangle X over triangle T, delta X over delta T. The change in distance over the change in time. That means my formula will look like this. So I'm just going to plug in my numbers here. Make sure I use the same colors. My formula is going to look like triangle X over triangle T. And then that equals, what am I trying to find? I'm trying to find my speed, which is V. So now I have my equation. Now I'm going to go back to the problem and I'm going to find my other components. So where is my distance? How far did Sarah run? Well, she ran, right here it says 100 meters. And how fast, what was her time? She ran it in 5.95 seconds. So now I just match up my colors, and I can plug them into this equation. So we said our distance was 100 meters. Might seem tedious to do this color coordinating, but it keeps everything in order. And then our time was 5.95 seconds. And that is going to give us, when we do our calculation, that is going to give us our speed, which is a rate, and which is meters per second. So, if we plug it into our calculator here, give you a moment, see if you can find it. We find that our answer is 16.8 meters per second. which is insanely fast. When you think about this number, picture 16 meter sticks, almost 17 meter sticks lined up. That cheetah is covering that distance in 1 Mississippi. That's a very, very fast cheetah. So that's how we answer question 1. All right, let's look at number 2. So if we read number 2, it says, a hawk flew 600 meters in 1 minute. A sparrow flew 400 meters in 30 seconds. Which bird was faster? So this problem kind of has 2 questions in it, and we need to split it up between the hawk and the sparrow. So let's first set up the hawk here. And what are they asking for? They are asking which bird is faster, which tells us that we are looking for speed. So if we go over to our triangle, we can delete speed. We can cover speed because that's what we're trying to find. And what are we left with? Delta x over delta t, distance over time. So if we look at the hawk first, how far did the hawk go? It went 600 meters. Whoops. It went 600 meters in how much time? 1 minute. The sparrow went 30 seconds, but it went 400 meters. Now, your brain should be going off right now. What is not the same? The blues, the time. One is measured in minutes, the other is measured in seconds. If we need to compare these 2 birds, we have to get that to be the same. And we'll do that here in a second. So let's just answer both of these first. So we have 600 meters over 1 minute. Now, we could solve this, but what's that answer going to be? It's going to be 600 meters per minute, right? This is already a speed rate. So we're just going to keep it as it is. But if we look, breaking my rule. Gotta make this guy blue because it's time. So let's take a look at the sparrow. The sparrow went 400 meters over 30 seconds. Now, there's a couple ways that we could do this, but we need to get those times to be the same because right now we can't compare the hawk and the sparrow. Why? Because the times are measured differently. But what could we do to get them to be the same? Well, there's 2 options. One, we could either bring the minute and convert it into seconds, or we could take the seconds and convert it into minutes. Now, the second thing we could do is we could estimate, right? How many seconds are in a minute? 60, right? So the sparrow flew half as long as the hawk. So the easy thing that we could do here is just multiply the sparrow times 2, right? Because that will get us to 1 minute. So if we multiply both of these by 2, then we determine, right, if we multiply this by 2 and this by 2, this then results in 800 meters over 1 minute. Now, there is a fancy ratio way to do this where we can cancel out things. I know we're skipping that, but we're keeping it simple, right? So now we can easily compare the 2, and which one went further, which one went faster? Well, 800 compared to 600, which one's higher? And we figure out that this one went faster. The sparrow went faster, 200 meters per minute faster than the hawk. All right, last question. If you swim the same distance in less time, are you going faster or slower? Use the speed equation as an example to explain. So, this is my example. Let's imagine Mrs. Ward and Mr. Franchina, right? They're in this scenario, right? So they both swim a certain distance. They both swim the same distance. Let's say Mrs. Ward swam. Let's say Mrs. Ward swam, let's do 1,000 meters. Let's keep it easy. 1,000 meters, and she swam 1,000 meters in 500 seconds. Oops, let's keep our colors the same. Now, why am I setting up like this? Well, because in order to find speed, right, that's how it's going to look. Delta x over delta t. Now, how fast does that mean she's going? That means that she is swimming at a rate of, did you do the math? 2 meters per second. 2 meters per second. Now, let's say Mr. Francina says, "Oh, all right, I think I can do that in less time." So let's say he also swims 1,000 meters. But let's say he does it in 200 seconds. Now the question states, is Mr. Francina going faster or slower than Mrs. Ward? So this is going to tell us if he's going faster or slower. So 1,000 divided by 200 means that Mr. Francina will be traveling at a rate of 5 meters per second. Is that faster or slower than 2 meters per second? We just proved that this means Mr. Francina would be going faster, which makes sense. If you cover the same distance in a less amount of time, then you went faster than that other object or person.